Okay, this is lesson 1.7a, transformations, and this time we're talking about reflections. Two different types of reflections. We can have a vertical reflection, which is a reflection top to bottom or bottom to top, and we can have a horizontal reflection, which is a reflection from left to right or right to left. What's tricky is if you're reflecting horizontally, this would be a horizontal. You're actually reflecting over the y-axis. Usually when we think horizontal, we think x-axis, but reflection, we're reflecting over the y-axis, left to right. If we're doing a vertical reflection, we're actually reflecting over the x-axis. So if I had an object, I'm going to draw an N. If I wanted to reflect this N across or over the y-axis, well, I'd take a point on the N and I would put it in the same position on this side, same distance away from the axis. So this point looks like a little bit away. I would put this point here. And if I wanted this point, I'd put it here. So if I wanted to trace from here down, I would go from here down. And if I wanted this point, I would put it same distance away over here. And if I wanted to go from here up and to the left, I would go from here up and to the right. That would give you this. And then if I wanted to go down to get to here, I would go down to get to here. And that's a mirrored N. We've reflected this N horizontally. Vertical. Well, the one you're very familiar with is a parabola, so let's start with a parabola. I'm actually going to start it right on the axis to see what happens. My parabola is going to look like this. So what would a vertical reflection look like? Well, it would, if it was on the axis that you're reflecting over it, it's a shared point. It would become invariant. It actually doesn't change. So that point would stay here. This point would be down here. That point's an arrow. And if I was going down to my point, if I'm reflecting vertically, I'd be going up to my point. And then if I was going up to this point, this arrow would be down here. I'd be going down to get to that arrow. And there's a vertical and a horizontal reflection. So how do you know if you have a vertical or horizontal reflection from an equation? Well, if we have a function f of x, the a value, the value multiplying the f of x, multiplying the function is y. If we have a number multiplying y, well, that would tell us we have a vertical reflection. If that number is negative. So if we have a negative a value, a number in front multiplying the function, that's a vertical reflection. So here we go. If a, the number in front of the function that's multiplying, is greater than 0, no reflection. If it's less than 0, if it's negative, you're reflecting over the x-axis. To get a horizontal reflection, horizontal would be x's, you're acting directly on x. So if there's a multiplier on x that's negative, you're going to have a reflection. So that letter we use to designate that is K, A and K. A multiplies the function, that tells us vertical reflection. K multiplies the x, that tells us horizontal. If K is positive, there's no reflection. If K is negative, we're reflecting over the y-axis. So let's do a couple of reflections here. I'm going to draw a figure and pre-draw this one so you actually get to draw it with me. I'm going to draw negative 2, 2. That's my first point. And my next point is going to be 1, 4. My next point is going to be 4, 1. My last point is going to be 6, 3. And I'll connect them so you can see this transformation. Usually we wouldn't connect our dots, but it helps with transformations to see it. So let's do each reflection. Let's reflect over the x-axis and let's reflect over the y-axis. For reflecting over the x-axis, I'll use yellow. Oh, my yellow just broke. Oh, no, it still works. All right. Over the x-axis. So if we're reflecting over the x-axis, that would be a vertical reflection. The reflection, vertical. Let's see what happens to these points. All right, vertical reflection of the x-axis. So this is 2 units away from 0. So my next point is going to be 2 units away from 0, but down here. The coordinate of this point is -2, -2. Compare the points. What happened? Did the x change? No. Did the y change? The number is the same, but the sign's different. So what's happening is the sign of y changes. Does that make sense? Well, if you're multiplying f of x by a, if you're multiplying the function by a negative number, does it make sense that y is changing? Well, if the function is y, and you're multiplying it by a negative, yes, that makes sense that the y is changing. Let's think about this point. This point's 4 units away from the x-axis, so a reflection would also be 4 units away, but it'd be down here. This point would be 1, -4. Hey, the sign changed again, 1, -4. Scroll down. This point's 4, 1, so we'd be 1 unit away from the axis. And this is 4, -1. Again, the sign changes. 6, 3. That's 3 units away from the x-axis, so 3 more units down. That's 6, -3. Hey, the sign changes. If I connect the curve, or the dots, it's not a curve. I get this graph. And here we go. Oh, my highlighter did die. Damn. Oh, it's still good. All right. Here's our vertical reflection over the x-axis. What happened? The sign of y changed. I'll get you to try a reflection over the x-axis, over the y-axis. It'll be a horizontal reflection. And guess what's going to happen? Well, when you reflect horizontally, it's not the sign of y that's going to change. It's actually going to be the sign of x that's going to change. So I'll get you to try that one. You can pause the video and try it now, or you can try it after. All right, let's flip the page. Sketch the transformed function where f of x is 1 over x. So we have the reciprocal parent function. We're going to sketch, we're going to reflect over the x-axis, and then we're going to reflect over the y-axis. Actually, we'll just do one. Which one do we want to do? We did x-axis for the first example, so let's do the y-axis. Conveniently, they actually end up being the same graph. That's something we'll look further into maybe in our warm-up. But let's try reflecting this over the y-axis. So we need a couple points here. I'm going to pick some nice points. So like 1, 1 is a good one. 2.5 is a good one. 1/2 and 2. And over here, -2 and -1/2, -1 and -1, -1/2 and -2. There's some nice points. So let's reflect it over the y-axis. So what do we think is going to happen? Well, when we reflect over the y-axis, we're changing the x. So we might expect the sign of x to change. So if our original points are x and y, we're going to expect, well, the sign of x to change. So we're going to expect some negative x's if they were positive. And the y's we don't think are going to change at all because we're not changing the y's. We're just reflecting over the x-axis. The y is going to actually stay the same. So here we go. 1/2 and 2. If we reflect that over the y-axis, we're going to end up right here. And this point is -1/2 and 2. -1/2 and 2 from the original 1/2 and 2. So yeah, we're just changing the sign of x. X is 1 here. If we reflect it, it's going to be -1. X is 2 here. If we reflect it, it's going to be -2. And if we connect these with a curve, we end up with that same branch, but on the other side of the graph. Let's try this branch. If we reflect here, -2 is our x. If we reflect it, it's going to become +2. -1 is our x. If we reflect it, +1. -1/2 is our x. If we reflect it, +1/2. If I connect my curve, we end up here. And there we go. we've taken the f of x and we have reflected it. So what have we done? Well, if the original is f of x, this is f at negative x. We've taken the x's and multiplied them by -1. We've reflected it. What would the equation of this be? Well, 1 over negative x, which if we take the negative from the bottom and put it in front, it'd be the same as -1 over x. These are equivalent. That's why if we did this example, reflected over the x-axis, the negative in front actually would end up with the same graph. All right, we talked about invariant points in the previous lesson, but basically if you do a change, any sort of transformation, usually with reflections, and you end up getting the same point on the changed graph or the transformed graph as you did in the original, that point's called invariant. It doesn't change. So let's see what would happen if we did a horizontal reflection and a vertical reflection to our parent functions. Well, remember, for a horizontal reflection, we're acting directly on x. So in function notation, that'd be f at negative x. So everywhere there's an x, we're going to replace it with a negative. So we would have negative x. If we're doing x squared, acting directly on the x inside the function, this one's a little tricky. The function's squared, so there we go. The negative's inside the squared. For our square root function, the x is inside the root. And you might think you can't square root a negative. But if x is negative, if we plugged in like -4 times -1 would be 4, you can square root. And that makes sense. That'd be just a reflected square root function. For our reciprocal, we did this one already. Sorry, rational, we did this one already. It would be 1 over negative x. That's the one we graphed above. And for our absolute value, it would just be the absolute value of negative x. For a vertical reflection, this would be a reflection outside the function. Well, for the linear, it would be the exact same, because the negative would go on the function is x, so it would go in front of x. Technically, if we were putting brackets so you could see it, it would look like this, and it would look like this, but mathematically, these are the same things. For vertical, if we're acting on x squared, outside the x squared, it would look like this, in front of the x squared. For the root, it would be in front of the root. For the rational, it would be in front of the fraction, or on top. And for the absolute value, it would be in front of the absolute value. So the reflections, the negatives would be in front. If you had both, well, what would it look like? Well, for the linear, we'd have a negative in front, we'd have a negative inside, and that'd just be like the original. Which if you think about a line, if you vertically reflect it, then horizontally reflect it, you actually end up with the exact same line, which is kind of neat to think about, if it's the original function, the parent function. For a quadratic, we'd have a negative outside the bracket, inside the bracket, and squared. And we can't simplify these negatives in quite the same way, but if we square root a negative x, you do end up with just x squared. So it would be like negative x squared. So you could simplify that one. Our square root function, we'd have a negative inside and outside the root. For a rational, we'd have a negative on the bottom. We'd have a negative in front or on top. And if we simplify that, we wouldn't end up with anything. So that means if we took the rational and reflected it horizontally and vertically, we'd end up with the original again. For the absolute value, we'd have a negative inside and outside. Now, if you take the absolute value of a negative number, you do get a positive. So you could actually say that this is the same as this. And up here we could have said that, well, that's the same as this. Basically, what this means is if you do a horizontal reflection of the absolute value, it doesn't change the graph. Let's think about that for a second. Here's the absolute value function. If you reflected horizontally, this point would go here and that point would go there. They'd end up being the exact same points just on the other side, and you'd end up with the exact same graph. So a horizontal reflection actually doesn't change this graph. There's one other that it doesn't change as well, and that's the parabola. Think about the parabola. Similar shape, but a curve. If you reflect it horizontally, you don't actually end up changing the graph, so we could say that this one's actually just the same as x squared. Did you ever wonder maybe in this lesson why you didn't learn about horizontal reflections last year when you did parabolas? Well, the reason is because a horizontal reflection of a parabola doesn't change anything. So it was redundant. They didn't have to teach it to you. That's why you never learned it. But there are horizontal reflections in other functions, and we're going to explore those more in this course. Last example. Determine the equation, domain, and range for the following reflections of the graph f of x equals the square root of x. This just looks like two different sideways parabolas, but it's actually four different functions. I'll highlight the square root of x. We know that the parent function, square root of x, looks like this. This is f of x. So then what are these four branches? Well, these four branches are just reflections. So let's think about what they are. A vertical reflection of this curve, this this square root function, would give me this curve. And what's a vertical reflection of the square root? Well, a vertical reflection of the square root would be negative square root of x. Vertical reflection, f of x, would be the negative square root of x. What's this curve then? Well, this curve, get my yellow highlighter. Don't fail me now, yellow highlighter. Hey, not terrible. This would be a horizontal reflection. Well, what's a horizontal reflection look like? Well, that's acting directly on x. There's your horizontal reflection. What would the equation look like? Well, the negative would be inside the function, so inside the square root. There we go. So then what's this one? It's kind of here to here. It's like opposite. Well, this one's actually getting both reflections. It's either being horizontally reflected, then vertically reflected, or vertically reflected, then horizontally reflected. Order in this case doesn't matter, but what this function is negative f of negative x. And the function would look like negative square root of negative x. So here we actually have four different functions. And what I'm going to leave you with is I'd like you to write the domain and range of these three. I'll write the domain and range of the original. Domain starts at 0 and goes to the right. So x belongs to real such that x is greater than or equal to 0. Range, y start at 0 and go up. So y belongs to real. Y is greater than or equal to 0. There's the domain and range of f of x. I want you to try to find the domain and range of the other three transformations. That's it for reflections. Thanks for watching, and I'll see you next time.